Here we're graphing the function -3 plus e to the negative x by using transformations. So we start with our parent function, which here is, let's call it g of x, e to the x. So when we plug in an x in our parent function, we get, let's plug in -1, 0, and 1. When we plug in a -1 into e to the x, we get 1 over e. When we plug in 0, we get 1. And when I plug in a 1, I get e. And I want to transform it in two ways. I want to put the negative in front of the x. So our next function has e to the negative x. So when I plug in those same values, I want to plug in e to the negative x. So when I plug in -1 for x, then I'm actually plugging 1 into e to the x. So I get e. So when I plug in -1, I'm really plugging in a e to the 1. When I plug in 0, I still get 1 because the sign doesn't change the 0. And when I plug in 1, I'm getting e to the -1, which mapped to 1 over e. And then from there, I want to do another transformation to subtract 3, so shifting down 3. So then I get e to the negative x, -3, minus 3. So I take what I got in the blue column and I subtract 3. So e minus 3, 1 minus 3, or I'll just write a -2 for that one, and 1 over e minus 3. So my final goal is that green column. That is going to be the f of x. F of x is the green one. So I'm going to start with my parent function. I want to graph the parent function because I want to see that transformation. I'm going to graph it in gray so it's kind of in the background. It's just a guide. It's not the actual graph. So my parent function has a point at -1, 1 over e. 1 over e is approximately a little more than 1/3. So at x equal -1, 1 over e is right there. And then at 0, there's a point at y equals 1. And at x equals 1, there's a point at e. And e is approximately 2.7. So let's say 2 3/4. So that's 1, 2, about there. So my parent function looks like this. Now we're not asked to graph this here. I'm just doing it for a visual aid so I can see that being transformed. I know that I want to take that gray function and I want to reflect, so doing the negative x's, I'm reflecting over the y-axis. All the positive x's turn into negative, all the negative x's turn into positive. And then I want to take that gray graph and shift it down 3 units. That's my -3. So so I actually made the columns here so I don't have to draw all the graphs here. So we're really looking for that result. This is our result column where after we've done the reflection and the shifting down. So there's two ways to think about it. Either I can plot those points from my t-table over there in the green column, or I can look at this gray graph and actually shift it. So reflecting, I'm going to do that one first. So first, if I think about reflecting over the y-axis, then this point changes to here. And this guy changes to here. And this guy will still be there. But they also have to shift down. So shifting down 3 units from there, I go 1, 2, 3. So that means my point is actually here. I'll do that one in green. And then this guy shifts down 3. So that's 1, 2, 3. And this guy shifts down 3. So I go 1, 2, 3. And my asymptote, which used to be at 0, is shifted down 3. So that's actually at y equal negative 3. So here's my new graph. Whoops, not that smooth, but. And you can see from the table, these numbers, E minus 3, that's 2.7-ish minus 3, so it should be approximately about a negative 1/3. And we can see when x equals negative 1, our point matches up with that table. And the negative 2, actually that's an easy one, that's right there. And when x equals 1, I get 1 over e minus 3. Remember, 1 over e is about 0.37. So subtracting 3, I get negative 0.2, I don't know, 63 maybe, about 2 3/4. So that looks like it matches up right about there. So there's what my green graph looks like, my the function that I'm asked to graph. You can do the transformations on the 3 critical points, which we showed in the t-table, or you can transform the actual parent graph, which I drew in gray. So 2 ways to get that graph. So there's your graph for that function. And then we're asked to find actually this t-table. So we're asked to find the values of, I don't want an eraser, I want a highlighter. And I want a green one. For this function at x equal negative 1, 0, and 1. And those are all in this column right here. And we're asked for the exact values, so we'll use the e. I estimated the values with the negative 0.3 and the negative 2.63 just so I can look at the graph and see where those points should be on the graph. But for the exact values that were asked in part B of this question, I want the e in order to state the exact values. So there's my t-table for part 2. Or part B, I don't know. All right, so that I will enter into number 24 of the practice test. So looking for the graph, that looks like my green line here. It's shifted down 3 with my asymptote at negative 3. Notice that on this question in the practice test, it actually has a scale of 2. So that asymptote is at negative 3. So that's in the right spot. It also intercepts at x equals negative 2. The y-intercept is y equals negative 2. That's in the right spot, so it looks pretty good. Let me just see if there's any graph that's similar. All the other graphs are way off. So that is my winner. Okay. And then moving down to part 2, where I have to put in that x table. So we found when x equals negative 1, this function is e minus 3. And when x equals 0, the function's value is negative 2. And when x equals 1, I get 1 over e minus 3. Whoops, that's not a minus sign. Okay, and then my domain, I didn't answer these on the notebook, but you can see the domain, that's all the possible x values. So that goes forever left and forever right, so I can put infinity to infinity here. And the range starts at the asymptote, which is now at y equal -3, and goes up forever, but it does not go below the asymptote, so that starts at -3, not including -3 since it's an asymptote, and goes on forever. And we see the asymptote shifted down 3 units, so we get -3. Oh, darn it. -3. All right, then I will click submit. Twice. And there we go. So that's number 24 from the practice test for test 3.